Very good morning to everyone. So, so in the last turn, we are discussing about the electric charge and the current and unit of electric current. Okay. So I want to recall the topics which we have covered in the last class. First, we have discussed about the quantity of charge. Quantity, the term itself defines the definition. Quantity of charge means number of electrons, because charge always flow due to the flow of electrons. Okay, only electron is responsible for the flow of current. So the first thing we have discussed, quantity of charge. What is quantity of charge? The number of charge, or we can say electron, because electron is responsible for the flow of charge. Okay, so when drift form or flow from higher potential to lower potential, this potential term we will discuss in the higher classes. What is exactly a potential? Okay, so when there is a potential difference, only then the charge will flow. Okay, suppose there are 2 points A and B. If both have the same potential, charge will not flow. For the flowing of charge, there should be a potential difference. And how the charge flow? From higher potential to lower potential. Now, the next thing we have discussed about the unit of charge. Okay, so unit of charge we have discussed that SI unit is Coulomb, or we can say MKS unit is Coulomb, and the other unit in CGS system is state Coulomb, or we can say Franklin. Okay, now definition of Coulomb, that is given that when there is a electrolytic solution and if we flow 1 Coulomb of charge, then what happened? 0.00118 gram of silver on the cathode deposited. That's the definition of 1 Coulomb. And second, and the another thing we have discussed, the number of electron in the 1 Coulomb charge. So how many electrons are there? 6.25 into 10 raised to the power 18 electrons in 1 Coulomb charge. Now, other things we have discussed, that charge of 1 electron. The charge of 1 electron is 1.6 into 10 raised to the power minus 19 Coulomb. And that is the same as the charge on proton. But both the nature of charge on electron and proton are opposite to each other. Okay. Electron negative charge, proton positive charge. Now electricity as flow of charge. The rate of flow of charge in an electric circuit is called electric current. Means rate where you find the term rate. Rate means per unit time. So the charge flowing per unit time is called electric current, and the unit of electric current is ampere, and in CGS system is biot, B-I-O-T. Okay. Now the formula for the electric current, same from the definition, charge flowing per unit time. Q is the charge, T is the time, and I is current. And the instrument used to measure electric current is ammeter. That is ammeter. Okay. SI unit of charge is ampere. In MKS unit, in CGS unit, biot. Okay. Now, if we have to define 1 ampere of charge, how will you define? You just put this both the value 1 means when 1 Coulomb of charge flowing in a circuit, electric circuit or closed circuit in 1 second, that will be 1 ampere of current. And one thing more to remember, that electric current is always, the direction of electric current is always opposite to the flow of electron. Okay, suppose if the electron is flowing, suppose this is electron, it is flowing in this direction. Okay, suppose this is east and this is east direction and this is west direction, west to east. So the direction of flow of current will be opposite to the flow of electrons. That will be direction of current will be east to west. Direction of flow of electron is if west to east. So direction of flow of current will be east to west, just opposite to the flow of electron. Now the unit we have discussed about the current is ampere, and there are bigger unit and smaller unit. So here first this 1 ampere, bigger unit. that is kiloampere. Multiply by 1000. Kiloampere, 1 kiloampere. Another is mega ampere, that is 10 raised to the power 6 ampere. 1 mega ampere, capital M. And the smaller unit is, you can see in your book on page number 125, that is milliampere and microampere. Okay, milliampere 10 raised to the power minus 3, or we can say 1 upon 1000. And microampere is, that symbol is mu. This symbol is called mu. Okay, 10 raised to the power minus 6 ampere. That is the smaller unit for measuring current. Now, relationship between current, number of electrons flowing through the electric current, electric circuit, and time. So the relation is very easy between the number of electrons. So we know that as the number of electron increases, the amount of current will increase. As the number of electron increases, suppose we can say this much electron is flowing, 6.25 into 10 raised to the power 18. So how much charge is flowing in a circuit? Who will answer? If this much electron is flowing in a circuit, how much charge is flowing? Who will answer? Anyone? Okay, Sadhgi Singh. Yes. Sadhgi, you can unmute yourself and answer.
1.6 into 10 raised to the power minus 90.
No, I am asking if this much electron is flowing through a circuit, so how much charge will flow? Okay, Ansh Jaiswal.
Good morning, sir.
Good morning. What will be the answer?
Hello?
I can listen.
1 Coulomb.
1 Coulomb. That's the correct answer. Very good. So now you can put your hands down. We have discussed in 1 Coulomb there are 6.25 into 10 raised to the power 18 electrons. So in the reverse way, we can say if 6.25 into 10 raised to the power 18 electron is flowing, so the charge will be 1 Coulomb. Okay, now we have to derive the relationship between the electric current, between current, number of electrons flowing through an electric circuit in unit time, or we can say in however time. Now Q equals to NE. Okay, now charge, if number of electron increases, amount of charge increases. You can see here, if 6.25 into 10 raised to the power 18. Okay, so for this electron, how much charge is 1 Coulomb? If we double it, double means if we double it, 12.5 into 10 raised to the power 18, 25 into 10 raised to the power 18, 50 into 10 raised to the power 18, 100 into 10 raised to the power 18. Now you have to answer me. This Ansh have answered that this for this much electron, 1 Coulomb charge. Now who will answer for 12.5 into 10 raised to the power 18 electron? Okay, Ankita Verma. How much electron? How much charge?
Sir, two coulombs.
2 Coulomb. Okay, good. You can mute yourself now. Now, so 25 into 10 raised to the power 18. How much electron?
3 coulomb.
Sorry, how much? Okay, 3 Coulomb. Mukund Singh.
Yes, sir.
Answer for this third one, 25 into 10 raised to the power 18.
Sir, 3 coulomb.
Okay. Abhigyan.
Sir, 4 Coulomb.
4 Coulomb. Okay, that's the correct answer. 4 Coulomb. See, for 2 Coulomb, 12.5, we have doubled 12.5 into 2, 25. So here also double, na? 2 Coulomb will become 4 Coulomb. Now here again double, 25 double means 4, 8 Coulomb. Here 16 Coulomb. So we can see that as the number of electron increases, charge will increase. Okay, now you can put your hands down. Ayush, you have any doubt? You have any doubt? Okay. Arsh, you have any doubt?
Sir, good morning, sir.
Good morning. Yes, what happened? What happened, Arsh?
Sir,
Hmm.
sir, you had tell Q is equal to NE.
Hmm.
Sir, NE belongs, sir. What is NE?
I'm just coming on this point. Okay. Now, E for charge of one electron. E means charge of one electron, and N is the number of electron. So E, we know charge of one electron is 1.6 into 10 raised to the power 90, and N is the number of electron. As the number of electron increases, charge will increase. Okay. So N for number of electrons, and E is charge on one electron. Okay. Now, so this parameter Q for charge and for number of electron, E means charge on one electron. Now here we know I is equals to Q by T, and we have just discussed Q is equals to NE on T, because Q equals to number of electron into charge on one electron. Now the expression becomes Q equals to NE upon T. Now this parameter I for current and for number of electron, E is equals to charge on one electron and T is time in second. Now coming on the next topic, electric cell as a source of electricity. Electric cell. Okay, you all know about the electric cell that we use in clock, torch, or we can say remote, the TV remote, various places we use the electric cell. Now it is a source of electricity because it produces electricity. Sometimes we use electric cell to light a bulb or just move a motor, small motor. So it is true that electric cell produce electricity. So can you tell me which form of energy change into which form in electric cell, as you have discussed in chapter energy? Okay, Ankita Mishra.
Sir, chemical energy into potential energy.
Potential, not electrical energy.
Sir. Electrical potential energy, sir.
Yes. Okay, so chemical energy is the energy is in the stored form in the cell, or we can say battery, and due to the some chemical reaction, it changes into the electrical energy. Okay, so electric cell acts as a source of electricity. Now we know that in order to produce electricity, order to produce current, what we need? We need a potential difference, because if there is a potential difference, then only charge will flow, electron will flow. So electric cell, what happened? The electrolytic cell, there are some electrolytic cell, that is anode and cathode. They keep their difference of potential difference, and due to the potential difference, what happens? Charge is low. Now we will see the point wise what is given in the book. To keep an electric current flowing between two ends of a conductor, it is necessary to develop an excess of electrons on one end at the conductor and deficit of electron on the other conductor. So what happened in the electric cell? There are two things. First one is cathode and second one is anode. Okay, and just remember the point, properties of charge we have discussed, that unlike charge attract each other. Unlike charge, if there are two charges, positive and negative, what happens? They are unlike, they are opposite in nature. What happens? They will attract each other. So in order to flow electricity, what happened? There should be a potential difference. Electrons should be flow from one end to another end. If the electron will flow, then current will develop. Current will flow in the opposite direction of flow of electron. So this is due to the chemical reaction, and this type of chemical reaction we will study in the 9th, 10th class. There are various types of cell: galvanic cell, Daniel cell. Okay, so just for your level, you just understand this. Due to the chemical reaction, there is a potential difference develop, and if there is a potential difference, then what happens? Current will flow, electron will flow from higher potential to lower potential. Now, so where is the excess of electron? Here is excess of electron on cathode. Okay, here excess of electron. excess of electron. Okay, and here is deficiency of electron. Means here number of electron is more, here number of electron is less. So this cathode is negatively charged and this anode is positively charged. So what happened, there is a positive charge and there is negative charge. So what happened if there is a deficiency of electron? Okay, so due to this electron transfer towards this place, means cathode to anode, this cathode to anode. So as the electron flow from cathode to anode, what happened, current produced and current flow. And what is the direction of current flow? Just opposite, anode to cathode. Electron flow cathode to anode, cathode to anode. Okay, and current will flow just opposite to the flow of electron, anode to cathode, anode to cathode. So the first thing we have discussed in the electric cell, we have to remember there are two things, cathode and anode. Cathode have excess of electron and anode have deficiency of electron. So what happened, the electron from the cathode transfer or flow from cathode to anode, and due to the flow of electron, what happened, there is an electric current induced or generate, and the direction of electric current will be anode to cathode. And one thing more, where there is a there is a more electron or excess of electron, that terminal is called negative potential. Means cathode will be termed as negative potential and anode will be positive. So positive potential, or we can say negative potential. Anode will be positive, cathode will be negative. So in summarized form, for the electric cell, there are two things, cathode and anode. Cathode, don't confuse with that cation and anion. Cation there is positive and here cathode is negative. Okay, so cathode, for cathode, two things we have to remember. It is negative potential, okay, and excess of electron, anode, positive potential, and deficiency of electron. Okay, so my question is that from where electron flow, from which terminal to which, from where to where the electron flow? Who will answer? From where to where the electron flow? Okay, Arshaiman.
Sir, from minus to plus. Sir, from cathode to anode.
Cathode to anode. Okay, and for the current flow from?
Sir, current flows. Sir, then it will flow from. Sir, current flow from minus to plus.
Just okay. Anvesha Gupta. What is the flow of electron? What is the direction of flow of electron? Cathode to anode or anode to cathode? Yes, Anvesha Gupta. Okay. Sadagi.
So the electron moves from cathode to anode.
Cathode to anode. And direction of current?
Anode to cathode.
Very good. And direction of current will be positive potential to negative potential.
Negative.
Okay, that we have discussed at just the beginning of this unit. Okay, fine, you can put your hands down. Now where we use cell, we use this cell in torch, transistor, radios, bicycle lamps, small tape recorder, and button cells in that hand clock we use. Okay, this watch we just button cell, this much size. Okay, so the in watch, these cells are called primary cells. So there are two types of cell. Primary cell cannot be recharged. Once you use, you have to throw it. Means When the chemical reaction ends, what happens? There is no potential difference. There will be no flow of charge. There will be no electricity. Means cell will not able to produce electricity. At that time, what happened? We have to replace the cell with the new one. So this cell is called primary cell because it cannot be recharged. But in our mobile, we recharge it. So that cell is called secondary cell or secondary battery. And the storage cell. These are used in cars, trucks, tractors, motorcycles to provide electric current for headlight and the horn. So what happens? These are secondary cell and they can be recharged. So two types of cells are there: primary and secondary. Primary cell, you have to remember that primary cell cannot be recharged and secondary cell can be recharged. Means it can be reused after recharging. Now electrical resistance or resistor. Okay, before starting electrical resistance or resistor, I want to ask a question which is related to your chemistry chapter, metal and non-metals. Which metal have the highest melting point, boiling point, you can say? Okay, Arshad. Yes, Arshad.
Sir, tungsten.
Okay, Anvesha Mishra. Just raise your hand again. Okay.
Sir, tungsten.
Okay. Okay. Okay, Anvesha Gupta. You just raise your hand and don't answer. Why it is? Okay. Ankita Mishra.
Sir, in metals it is tungsten and in non-metals it is diamond.
Okay. Can you tell me the symbol of tungsten?
No, sir.
Okay.
I don't.
No problem. See, tungsten have highest melting point. Tungsten. And it is used in the filament of bulb. And the symbol is capital W. Okay. So just for your knowledge, now we will start the topic resistance. Okay. So resistance is the physical quantity that measures the opposition offered to the flow of current by a conductor. Okay. If the current is flowing, so there is always a resistance, means opposite force, just like a friction we have discussed in physics. I think we have discussed friction. Okay, so as the electric current flows through the conductor, there is an opposition or any physical quantity which offer hindrance, or just we can say opposition means rukawat. So that term is referred as resistance of the electric circuit or resistance of this circuit. Okay. Now, in an electric bulb, a small coiled thin wire of tungsten is provided, which is connected to two terminals of brass. When the terminals of bulbs are connected to a dry cell through a wires of copper, the bulbs start glowing. Okay. So in 100-watt bulb or in small wall bulb, you can see the tungsten. Okay. You can put your hands down. So this tungsten have very high melting point. You can put your hand down. Okay. If you have any doubt, we will discuss in the evening session. Okay, or you can ask me the personally. I will clear your doubt. Okay. So for now, I think the time is over. So we will start this topic fresh tomorrow, because tomorrow we have a class. Okay. For now, just thank you. Bye. Take care, everyone.